Knowing the basics about Vue, which we do by now, is of course important. It's the most important part. But in my opinion, it's also important that you understand what Vue does behind the scenes, how it works behind the scenes. And that is exactly what we're going to explore in this module. Now, I will say this module is optional, at least the majority of it. There are 3 lectures which you should not skip. The lecture about refs and the 2 lectures about the Vue app lifecycle. You can skip the rest of the module for now if you're not interested, though I strongly recommend that you don't skip it, or you at least come back later, but you will definitely get the most out of this course if you go through this module right now. I mean, after all, that is why I did add it at this point of time in the course. Because having that extra behind the scenes knowledge will help you overall as a Vue developer. Because if you understand the tool you're working with, you're able to work with it better. Specifically in this module, we will explore how Vue works under the hood, how its reactivity system works under the hood, and we'll also understand how it uses a concept called the virtual DOM to efficiently update what you see on the screen. Now for this module, I prepared another very simple project for you. You find it attached. And there I already have a simple Vue app created with Create App, where we have 2 pieces of data, the current user input and a message, where we have 2 methods, one to change the current user input to the event target value, and one to set the current message to the current user input. And all of that is connected to some HTML code. That is the section we're controlling with Vue. This is what triggers the save input method. Here we trigger the set text method, and here we output the message. And then we got some styles, which we of course can ignore, though these are largely the styles you already know anyways. Now, this app here is very simple. Vue is awesome is something I can enter here, and if I click set text, that's the message showing up here, and that is achieved with a combination of data, methods, and then of course event bindings that trigger the methods, and interpolation to output the message data. Now that's all something you'll learn about in this course, and I'm not going to bore you by repeating this again here. If that is still unclear, you should go through the previous lectures and modules again. Now what I want to explore here is how Vue does this behind the scenes, this automatic updating here. If we change the text here and set it, this part of the page we as a user see is updated by Vue. And that's this built-in reactivity which Vue has, which is one of its core features. Essentially, Vue does one important thing. The data you define here is something Vue keeps track of. I mentioned before that it would take this data object here and merge all your properties in here into a global behind-the-scenes managed object. The same object where your methods are merged into, by the way. And indeed, this is what is happening behind the scenes by Vue. It also does other things like ensuring that this points at this global object. But when it comes to the data, the important and key thing which Vue does is it turns your data object into a reactive data object by essentially wrapping your properties with a JavaScript feature called proxies. In JavaScript, there's a built-in feature, which is called proxy, which Vue leverages under the hood to wrap your properties here and to be notified whenever you assign a new value, like here with message. When I set a new value to message, no matter if that is another data property or a hard-coded string like this, no matter what it is, when you assign a new value to message, Vue is made aware of that. And that's important. If Vue would not be notified about this new assignment, it could not go ahead and update what you see on the screen. It needs to be notified by changes like this so that it recognizes that it should scan the controlled HTML code for usages of that changed property, like here, message is being used here. And then when it sees those usages and it knows that message changed, it goes out to the rendered page, to the screen the user sees, it goes to that screen and finds the appropriate place there where this dynamic content is displayed and updates it there on the screen as well. And that's this built-in reactivity which Vue does and uses behind the scenes. Now, how does that work though? I mentioned that a feature called proxies would be used. Let's explore that in greater detail. For a second, I will leave Vue to dive into that proxy thing which is built into JavaScript, which Vue uses. And let's leave the Vue world here and write some vanilla JavaScript. We have a variable message where I say hello. So this is a regular JavaScript variable. It has nothing to do with Vue. Now the interesting thing about JavaScript is that if I now have a new long message, which is my old message plus, let's say, world, I can of course console log that here, and we would see hello world. If I save that, open the console, and reload, we see hello world here. Now that shouldn't be too surprising. But now if we change the message thereafter to hello and a couple of exclamation marks, if I console log long message again, and I reload, I still get hello world. I don't get all these exclamation marks here. Instead, I just have one exclamation mark after hello. Because JavaScript by default is not reactive. That is really just something which Vue adds for us. JavaScript by default is not reactive. If we have a calculation like we have it here, where we use a variable, and we change that variable thereafter, that calculation here is not re-executed. JavaScript doesn't note that message changed and that it was used here. So that is how JavaScript works, and Vue works differently. Vue has a built-in mechanism to be aware when message changed so that parts of the app that rely on message can be updated. And as mentioned, for that it uses proxies. So let's see how proxies could work. For that, let me remove that and let's create an object, data, which is just an empty JavaScript object, again, not related to Vue. And let's put the message in here, hello. Now we can wrap this object with a proxy in JavaScript by creating a new proxy. And that is a constructor function built into modern JavaScript. Therefore, make sure you're testing this code in a modern browser like Chrome. Now we can store that proxy in a constant, and this proxy wants the object it should wrap, in this case, data. But it does not just want this. Instead, it wants a second object as a second argument, and that will be an object full of handlers for that wrapped object. Now I'll come back to what that is in a second. Let's first of all create such a handler object here. This handler object can now use certain features. It can set up so-called traps, which proxies support. For example, set traps. You do this by adding a set function here in the handler, and as an argument, you will automatically receive a target, a key, and a value. Now to understand what this does, let's console log target, key, and value here. And let's now pass this handler object as a second argument to our proxy. Now I said that the proxy would wrap this object, this data object, the first argument, and indeed it does. So on the proxy we can indeed access message just as if we would have a message property on the created proxy object. Because actually we will. It wraps this data object. This object has a message, so the proxy also has one. And we can set this to hello with a couple of exclamation marks. Now let's save and reload. And what you should see here is that you get 3 console log messages because we have 3 console logs here. The first one, the target, is essentially the object that was wrapped here. That's just your object that was wrapped. The second one, the key, is the property that you just set a new value to. And the third one, the value, is the value that was set. And that hopefully shows you what a handler does. With that, we can define a setter function, which is triggered whenever a property is set to a new value on this proxy. And then we can find out which property that is, what the new value is, and which original object we wrapped. And we could then use this if we had another property here. Let's say a long message, which initially is hello world. But we want to ensure that long message changes if message changed. Let's say that's our goal. Now, by using a proxy and setting up such a handler with a so-called set trap, we can implement this. We can check if the key we're setting is message. So if we're setting the message property, and if we do, we want to set target long message equal to the new value we assign for message plus world. And thereafter, we also want to make sure that the message property itself is set, so we set target message equal to value. And the interesting thing can now be seen if we console log proxy.long message thereafter here at the end, after setting the message to hello with multiple exclamation marks and after updating our handler here. If we now reload, we see that down there from line 40, we're outputting the long message, which now picks up all those extra exclamation marks. So long message was updated when we set message. So here we built our own reactive system for tracking one property and updating another property when that one property, the message property here, changed. And in a nutshell, and of course with a couple of simplifications, that is what Vue does under the hood. It keeps track of all your data properties here, and whenever such a property changes, it updates the part of your app where that property was used. For example, it knows that it needs to update this paragraph where you're using the message. And it does that by wrapping your properties with proxies so that it has a chance of finding out when you're setting a new value. That is how Vue works. And of course, it has a way more complex way of doing that than I did it down there. And of course, it also has computed properties and watchers which are triggered when a property changes. But that's just the in a nutshell approach, which hopefully gives you an idea of how Vue works under the hood, so that this magic, which Vue adds and which is amazing, is a bit less magic in a positive way. Now that we explored reactivity, I already want to leave it. I already want to leave this example because that really is all I think we should know for now of how Vue's reactivity works under the hood. It's not all we should know about Vue in general, though. For example, you might have wondered if you can only have one Vue app per page. And maybe you already tried out working with multiple apps, because yes, you can have multiple apps. Here, and thus far in all the lectures and modules, we just haven't had one app. And we mounted that to one part of our HTML code, which would then be controlled by that app. But you can absolutely have more than one app if you wanted to. So if we add a second section here with an ID of app 2, we can absolutely create a second app, maybe name it app 2 here, with view create app, which we mount to this app 2 ID section. And in here we can do the exact same thing as we did in our first app. We can also return a data object here. We can have a data property here, like a favorite meal, pizza. And we can then, of course, output this here in our second app, the favorite meal. If we do all of that and save that and reload, here is our second app. Now it's missing the styling because I actually set the styling up to target the app ID. But if we would target the app 2 ID as well, we would get the exact same styling as before. So if you quickly find all the places in the styled CSS file where we target the app ID selector, simply add the app 2 ID selector with a comma as well. Also here. And here. And of course also for the input, if you plan on using one in your second app, and all the other styles. Now, since I don't use a button and so on in my second app, I'll omit this. And with that, if I reload, we see this in a nicer style. Now, of course, you can't use data from another app. So here in my app 2, in this section, which is controlled by the second app, I can't output the message, which is part of the data of the first app. This does not work. If I do that, you see nothing here, because message is not a data property of the second app. It's one of the first app. And these two apps have no connection, which is important, by the way. Each Vue app works standalone. There is no connection between them. These are really two different parts of your HTML code controlled by two different apps with no connection between the apps. So this here does not work because this is the data from another app. And therefore, multiple Vue apps are definitely something you might want to use if you have different independent parts on your screen that should be controlled by Vue. If you have a part that needs to work together though, for example, an input which is connected to the button which ultimately influences what's in the paragraph, if you have that, then this all should be controlled by the same app, of course. So we can have multiple apps, and I already mentioned that we control different parts of the HTML code. Now, of course, it should be needless to say that you shouldn't control the same HTML part with different apps. And you also can't use one app to control multiple HTML parts. It's one HTML part per app. And also the term HTML part or controlled HTML is not entirely correct, though I used it because I think it's easy to understand. The official term is template. By mounting your app, your Vue app, to a certain place in the DOM, in the HTML code, you make that part of the HTML code the template of that Vue app. So this section is the template of our first Vue app, which is mounted with this selector to this section. And that other section is the template of our second Vue app. And I'm emphasizing this because we're also going to hear about the term template later again. There also are different ways of defining your template of an app. This here is definitely the most common and most convenient one. Writing HTML code and then mounting your application to it, this makes a lot of sense. But actually, it's not the only way of adding a template. And I want to show this here at the example of app 2. You can also add a template to a Vue app by adding the template option to your app configuration object. This template option wants a string. And to write multi-line strings with ease, I will use backticks here, really just so that I can write multi-line code. So these are not single quotes, that's a backtick, which is a different character on your keyboard. And now we could, for example, grab this paragraph here and cut it from the HTML file and instead add it in this string here. This now is the template of this second app. And actually this was the template before as well. We controlled this section, so anything inside of the section was our template. Now I'm just defining this differently. Now we still need to mount this app because Vue still needs to know where to display this template with the actual value for favorite meal when it is rendered on the screen. So we still need to mount it, otherwise Vue wouldn't know where to add this paragraph on the page. But with that, if I saved it and reload, you'll see the same output as before. The template is just defined differently. Now in reality, you will most often use the approach we used thus far. We get nicer syntax highlighting there, it's easier to understand, and there is no great reason for using this string-based template. We will, however, learn about a different way of defining a template and of writing Vue code in general in a couple of modules. Not a drastic change, but a nicer way of doing that. So that's also why I'm emphasizing this template part right now already. For the moment, just be aware of this template concept and that of course there's nothing wrong with the approach we used before, but that with that approach, we in the end made all the content of the Vue-controlled HTML part the template of that app that controlled that part. Now here's a lecture which I recommend that you do not skip in this module, because I'm going to show you a different way of getting a value out of such an input element. Thus far, we're listening to the input event, and therefore with every keystroke, save input is fired, and in the save input method, I in the end just save the current value of the input to the current user input data property, so that we can eventually use that property later to assign the entered value to our message. Alternatively, as you learned before, we could also use vModel and bind that to our current user input property like this. That is also something you learned about in the course before. Then we can omit this input binding here. But whatever approach we use, we basically log what the user enters with every keystroke. Sometimes that is what you need, for example, because you want to validate the user input with every keystroke. But sometimes that's also just overkill. And in such cases, Vue has a feature that allows you to retrieve values from DOM elements when you need them instead of all the time. And that feature is called refs. Here's how you add it. Instead of adding this event listener, which you still could add in addition, but which we simply won't need anymore now, instead of having that, you add a special attribute to this element, the ref attribute. Just like the key attribute, which we used with v4 before, the ref attribute is a non-default HTML attribute, so the browser doesn't know it, but Vue understands it. You assign a value here, which is any string identifier of your choice. For example, user text. But again, this is totally up to you. And you can also not just add refs to input elements, you can add them to any HTML element, to paragraphs, headers, sections, inputs, text areas, whatever you need. Now, why am I doing that? Because Vue detects such refs and stores them internally. It basically memorizes that you want access to the input element. And in the JavaScript code, you can then get this access. Here, in this case, inside of the setText method, because that's where I need the entered value. Instead of using this approach, I can now set this message equal to this, and now a special property which is provided by Vue, the $refs property. $refs is a property provided by Vue. All Vue-provided properties start with $signs to make it clear that this is a built-in property. This is an object full of key-value pairs where the keys are the ref identifiers you set up in your template, for example, user text. So here we can access .user text. And this now simply points at the DOM object for this input element. So the JavaScript object we can use in vanilla JavaScript as well when we got access to a DOM element. So now here we can get access to the full input element. And to show you what this means, I'll comment this out and log it to the console for now. If we now open this console and reload, and then click set text, you see the whole input element is logged here. And if we use console dir instead of console log, and click set text again after reloading, here is the inspectable object. And this is really the JavaScript object representation of this input element with all the properties that has. So this is not Vue specific, that is the vanilla JavaScript object we could use and work with in any JavaScript code. And for example, here we got this value property. Essentially, the object we're logging here is the same one we get access to with event target, which is why we can access value there as well. But now we're not doing this with every keystroke, but instead only when set text is emitted, which happens when this button, the set text button, is clicked. So now we can access value here, and with that, if we reload, and I set the text to Vue is awesome and click set text, this works as before, but now we're not logging the input with every keystroke, but we only extract it with help of that refs feature when we need it. And that's why refs is a feature worth knowing and why you shouldn't skip this lecture. Now we already learned about a couple of nice behind the scenes and core features of Vue. Let's now understand how it actually updates what we see on the screen. Of course, we learned about its built-in reactivity, but this is basically just how Vue detects that an update is needed and where the update is needed. But performing that update in a performance-optimized way is yet another thing. And I mentioned this before, and I'm going to show it to you again. If I inspect an element here in the browser developer tools, you will notice that if I type here and I click set text, only the paragraph with the text inside of it flashed here on the right. So Vue only updated this paragraph and nothing else on the screen. And Vue does that with a concept called the virtual DOM. So how does that work and why does Vue update the DOM like this? We got our Vue instance, our Vue app, and we got the DOM, the browser DOM, so the HTML content rendered by the browser, and therefore essentially what the user is able to see on the screen. Our Vue app, our Vue instance, stores data, computed properties and methods, and the browser DOM is then influenced with help of that Vue-controlled template. That template content is rendered to the DOM, and during that rendering process which Vue controls, the dynamic parts and placeholders, the interpolations and bindings are removed and the actual values are inserted. I mean, that is what you can see here as well. We got the paragraph tag with the test text being rendered here. We don't have the curly braces here, yet we of course do have them here in our template. On the button, we got this add click thing, which is an instruction to Vue, and that's why we don't see it in the actual DOM that's rendered in the browser, because those Vue instructions are removed by Vue when it renders its template to the DOM. So when it basically converts its template to the actual HTML elements that should be shown on the screen. That's what Vue does here. And therefore, if we have data like this, we see something like this on the screen instead, if we use interpolation for outputting the data, for example. Now, of course, our data and our computed properties might change. For example, because the user entered something or clicked a button. And those updates should of course be reflected, but Vue should not re-render the entire page every time something changes, but only the parts that did change. Because if Vue would re-evaluate and re-render the entire page, well, that would not be great for performance if just one piece of text changed. For example, if just the title changed, but not the text property here, then only the h2 tag which outputs the title should be updated, and not the paragraph. Now, how could Vue ensure that this is the case, that it does not re-render the entire screen? Well, one possible solution would be that it basically compares the old DOM values with the new ones. So it basically goes through the entire rendered DOM, sees which content is in there, and compares that to the content it has stored in the data properties of the Vue app. And if there's a difference, it updates it. Well, it could do that, and at least it would not update the entire screen then, but actually it's not what it does, because reading the entire real DOM, which is rendered by the browser, all the time whenever something changes is also pretty performance intensive. Maybe not as bad as re-rendering the entire page all the time, but definitely not great. Instead, as mentioned before, Vue uses a concept called the virtual DOM. It basically has a virtual copy of the real DOM, which is managed entirely in JavaScript and therefore in memory. It could look something like this: a bunch of JavaScript objects where Vue memorizes which HTML tag is needed and what the content of that tag is. And when data changes, it basically just creates a new virtual DOM, you could say, and compares the new virtual DOM to the old virtual DOM, and only differences between those two virtual DOMs are written to the real DOM. And that is way more efficient, because doing such comparisons and updates in a virtual DOM, and therefore entirely in memory, is way more efficient than doing it in the real DOM, which was rendered to the screen. And that's how Vue does that behind the scenes. Whenever we change something, whenever I change this text here, and I click Set Text, Vue detects this change thanks to the reactivity we discussed earlier in this module, and then it creates a new virtual DOM, compares it to the old virtual DOM, and detects the differences, and then updates the part in the real DOM where the differences were detected. That is what Vue does in a nutshell. Now, it should be needless to say that Vue has a bunch of optimizations in place that actually make this way more performant. In reality, it does not recreate entire virtual DOMs all the time. It has a bunch of optimizations for that. But this is beyond the scope of this course, and really also not something you need to know necessarily. You should just know how it generally works to be aware of what Vue does, that it's not all magic, but that it's pretty performant. Now, to conclude this module, we'll have our second lecture, which you should not skip. The first one was the refs lecture. Now we're going to talk about the Vue instance lifecycle, which is also important. We learned how Vue works under the hood, we learned about the virtual DOM, and that there are various steps for bringing something onto the screen. Sometimes you need to run code during those steps. And that's why Vue has a quite elaborate lifecycle where you can step in at any time to execute code you need to execute. And you will see some of those lifecycle hooks we're going to discuss now in action throughout this course, by the way. It all starts with us creating a new app and, of course, mounting it with the mount method to the HTML code, to the DOM, so that Vue knows where to render the app. Then, when it starts creating the app and starts bringing something onto the screen, it reaches a couple of points, a couple of lifecycle phases, which are also reflected in methods you can add to your View app configuration object to run code you might need to run at this point of time. For example, the first lifecycle phase, the first so-called lifecycle hook that is reached, is the before create phase. It's followed by a created phase. The difference is that before create is basically called before the app has been fully initialized, whereas created is called thereafter. At this point of time, we still have nothing on the screen though. After created, Vue just knows its data properties and it's aware of the general app configuration. But now is the time where the template is compiled. So where all the dynamic placeholders, all the interpolations and so on are removed and replaced with the concrete values that should be shown to the user. Thereafter, the before mount hook is reached. Before mount means that this is right before Vue is actually going to bring something to the screen. So right before we can see something on the screen. So now after created and before mount, we reach mounted. So that in the end just means that now we see something on the screen. Now the Vue app was initialized, the template was compiled, Vue knows what to show on the screen, and it handed those instructions off to the browser so that the browser really adds all the HTML elements with all the content we need as defined by our Vue app. So now we have our mounted Vue app, our mounted Vue instance. Now, of course, in most Vue apps, data changes at some point of time, and that then triggers a new lifecycle. Now we reach the before update hook, and thereafter the updated hook. This is a bit like before create and created. Before update is reached before the update has been fully processed internally by Vue in its app. Updated is reached once that has been processed. This, by the way, also means that at this point of time, the update is visible on the screen. So we don't reach mounted again because the template was never unmounted. So it always was visible. After updated, the changes just have been processed and have been rendered to the screen, whereas in before update, they haven't. Now, sometimes an instance can also be unmounted. A Vue app can be unmounted. We haven't had this scenario yet. It will become more important later, as you will see, but I can also show you how we could unmount an app in the next lecture. When an app is unmounted, all its content is removed from the screen and the app is dead. And we have two lifecycle hooks here as well. Before unmount, which runs right before it's about to be removed, and unmounted, which runs after it has been removed. You can, for example, use these hooks to execute any cleanup code you might want to do, send a HTTP request to your server to keep track of that app being unmounted, or whatever you need to do. Now let's see all those hooks in action to make it a bit clearer how they work. To see it in action, I'm back in app.js and I'll go back to my main Vue app, which is the one with this input field. Now I mentioned all those lifecycle hooks and I mentioned that these would be methods you can add to your Vue app. And with that, I don't mean methods you add in your methods option, because in there you really only add the methods you plan on calling yourself or which you want to call upon events like clicks. Instead, you add them right next to data and methods, anywhere you want in this app. So for example here, towards the end of this app configuration object. Here, we could add the before create method, which I showed on the slide. You just add it as a method like this, and here we can console log before create so that we get an idea for when this runs. And of course, you could do more than just logging here. You could send an HTTP request to a server, you could set a timer, you could do whatever you need to do. If I now expand this again, open the console and reload, you see before create being logged here. And actually, I'll comment out this log message here at the very bottom so that we're not confused by that. So let's go back to our view app again then, reload, and we see before create. If we do something else and go to the Sources tab here in the Chrome Developer Tools, we actually can also inspect our source code there. And I'm showing this to you here because there's something neat we can do with that. We can actually find the before create method here in the app.js file and click here to set a breakpoint. As a consequence, code execution will pause when this is reached. And if you now reload the page, you will see it pauses here, and you can always continue by clicking the blue play button. But the interesting thing, and the reason for why I'm doing this, is that you see there's nothing on the screen yet. As I mentioned, in before create, you won't see anything on the screen. At this point, actually, not even the view app will have been fully initialized. So let me click the blue button here to continue and remove the breakpoint by clicking on it again. Let's now add the second hook, which is the created hook. At this point of time, the view app was initialized internally, but it was not mounted yet. So visually, we'll still not see anything. If I reload in the console, we see created. And if we go back to sources and I add a breakpoint in the created hook now, if I reload, you see again at this point there's nothing on the screen, just as I explained. So let me remove the breakpoint and continue, and let's add more lifecycle hooks. The next hook in place is before mount. This triggers right before this app really is mounted. So right before we see something on the screen. So we'll still not see anything here, but we will see something in the next hook thereafter, which is mounted. So here, let me console log mounted. And let's then save this, go back to the JavaScript console and reload. And we see before create, created, before mount, and mounted. But again, it's more interesting if we go to sources and now add a breakpoint in before mount and in mounted. And now reload. And we first pause in before mount because that hook runs first. And you see nothing on the screen. If you now click resume, so this blue play button here, we pause on the next breakpoint, which is in mounted, and now you see something on the screen. As I explained, because at this point of time, this view app was mounted to the screen. It was initialized internally, all the data was processed, the template was compiled, and it's showing its output on the screen. So with that, we can also remove those breakpoints and resume again. Now with that, the creation lifecycle here is finished, but I mentioned that we would have data changes which also trigger their own lifecycle hooks. So let's see those in action as well. After mounted here, though as mentioned before, the exact position does not matter, but after mounted I'll add before update and console log before update here, and I will also add updated. The difference will be that in before update, we'll not see the changes on the screen yet. In updated, we will. So if we go to the JavaScript console in the DevTools and reload, we don't see those hooks being executed because nothing was updated in this app. It was created, but nothing was updated. So now let's enter a new text here. And if I click set text now, you see before update and updated. And if we go to the source tab again and add some breakpoints in before update and an updated, we can also see that if I change this again, for example, to add more exclamation marks, we now pause and we first pause in before update. And you notice that the text output here on the screen is still the old one, Because as mentioned, in before update, the update was not fully processed yet, it's not visible on the screen. If I resume, we pause and update it, and indeed at this point of time, the output has been processed and is visible on the screen. So again, I'm removing those breakpoints and resuming, and that hopefully shows the updating process. Now, as mentioned before, we also can unmount a View app even though we haven't done this thus far. We then trigger the before unmount and the unmounted hooks. And as also mentioned before, this unmounting process will become more relevant later. Nonetheless, let's see it in action now already. And for that, back in code here, I'm going to add the before unmount hook and console log before unmount. And I'm also going to add the unmounted hook and hence console log unmounted here, so that both those hooks are implemented and we log a message for them. But at the moment, this app will never get unmounted. We have no way of killing or removing it. But just as we have an app mount method, we also have an app unmount method to remove a View app. Now, you will rarely call this method in a real application though. Instead, you will later see a way more realistic scenario of unmounting apps. But at the moment, we're missing a key prerequisite for that, so we're going to work with that unmount method instead. We could set a timer here and set it to 3 seconds, let's say, and then have a function in which we call unmount, so that 3 seconds after the app was created and mounted, we destroy it, we unmount it. And if we now save that and reload, you will see that after 3 seconds, the app is gone on the screen and we see before unmount and unmounted. And of course, again, we could also go to the sources and simply add breakpoints here in before unmount and in unmounted, and reload and see how this pauses after 3 seconds. First in before unmount, at which point of time we still see the app, so that's the last chance to work with it. But then, if I resume, it's removed in unmounted. And that is the View lifecycle with all its hooks. In reality, you will only need a few of those hooks. Nonetheless, of course, I wanted to show them to you because this is the complete guide after all, and not the I show you some things guide. Nonetheless, we'll especially see hooks like created, mounted, or unmounted in action throughout this course, as well as updated. And with that, we can also leave this module. We now have a solid understanding of the basic features, and not just of how to use them, but also how they work under the hood. And with that, you already made a huge step in the right direction to becoming a Vue developer.